Okay, this is the review for test 4. We want to find the distance between 2 points and also the midpoint. So from here, we want to, what 2 formulas do we need to use from here? There's 2, and we're looking for, want to find the distance between these 2 points. And let's say we call this x1, y1, and x2, y2. Okay? Let's start with the distance formula. Dylan, what would we, what would be that formula? Okay, it's d equals the square root of x2 minus x1, close parentheses squared plus. Okay, yeah, y2 minus y1, parentheses squared. Now keep in mind, these are not square, this is a subscript. Now up here, this would be a superscript for the exponent, subscript. That kind of identifies 2 different x's in this case. Okay, and you want to label these points x1, y1, and x2, y2. So that would be the square root of 25 minus 20. Close it, parentheses squared plus, and then y2 is 25, again, minus 20, no, it should be 18. This should be 25 minus 18 here. For the x's, x2 minus x1, and then y2 is 25 minus 20. Close parentheses squared. All right, and so we get 25 minus 18, and so that'll be square root of 7 squared plus 25 minus 20, that would be 5 squared. And so you're always going to get a positive value because of these squares here. So that'll be the square root of 49 plus 25. And we have to add these 2 together, right? So we have 49 and 25, so that's going to be 4, 5, 74, square root of 74. Okay? And so you always want to see, since especially if you have an even number, you always want to see if you can get an even square root out of that. And an easy way, the easy way to do that is to go ahead, for the larger numbers, go ahead and divide by 4. And we see that the square root of 74, when we divide 4 into that, we get 19. So that means this, our distance is going to be what? This would be like saying the square root of 4 times the square root of 19. And so that gives us what? Yeah, 2 square root 19. Okay? All right, so that's our distance. All right, well, how about our midpoint? Travis? Okay, good. X2 plus, or it's not minus, plus, right? Basically what you're doing is you're getting the average of the 2 x's. Whether it's x2 plus x1 or x1 plus x2, technically the formula is x1 plus x2, but whether you put x1 first or x2 first, that really doesn't matter. Over 2, and then y1 plus y2, that's over 2 as well. And so this will be 18 plus 25. over 2. And then you're also going to have 20 plus 25 over 2. And you may get a fraction with that. So 18 and 25, okay, so that'll be 43 over 2. And then this will be 45 over 2. And you can just leave it as a fraction, okay. All right, so that's your midpoint and your distance formulas. Okay, and these play a part in our problems that we work with as far as a circle is concerned. All right, any questions with that? So it helps to write these formulas down before you start. Okay, and I would recommend that you do that. All right, questions? All right. Okay, that's basically the same thing. And find the distance between 2 points, also find the midpoint. Same thing there too. Okay, find the coordinates of the other endpoint in the segment given the midpoint and one endpoint. All right, it helps here to start with your equation. Okay, we have our midpoint and our endpoints. So we know that our midpoint, let me use a different thing here. We know that our midpoint is equal to, for our x's, midpoint for our x, would be x1 plus x2 divided by 2. And then our midpoint for y would be the same thing except for we're using y's. y1 plus y2 over 2. So if we're given our midpoint, okay, for the x is 7 equals to 14 plus x2, whether you use x1 or x2, that doesn't matter. We could just use x over 2. And now we just solve. So now we just multiply both sides times 2. So that's 14 plus x. And that would be equal to 14. And then apply minus 14. And we get x equals to 0. So this would be, we could say x2 is equal to 0. So in our x2, let's say this is x2, y2, this would be 0, comma, and then we got to find the y value. So now we do the same thing for the y, which would be what? Now, Harley? For my. Negative, okay, all right, you're still in here. You're up here. Negative 8 plus y over 2. Okay, then what? Equals to? Good, negative 5. Okay, so we multiply both sides times 2 there. Right, and we get negative 8 plus y equals to a negative 10. And then apply plus 8 to both sides. And we get y equals to a negative 2. So that would make this 0, negative 2 is our other endpoint. Okay, and that's our answer. Okay? So basically you're using the midpoint formula and you're working backwards. Okay? All right, questions with that? All right, and that's basically the same thing. Okay, the graph depicts the growth and cost of the line segment. Using the midpoint formula, approach approximately the cost during the year 1987. Well, 1987, that's going to be the middle, right, of your year. So you take these 2 points and you go ahead and you want to find your midpoint right here. Well, your mid-year is 1987, but you don't know what your cost is going to be yet. Okay, so you have so for they normally give you the values here. So this is about graph depicts the cost of line segment midpoint from approximately. So for 1983, use a finer. 1983, your cost, they give it to you here, 5,037. 5037. And then the other one, 1991, is 9977. Okay, so you have to get the values straight off the graph. Okay, since they want to know from 1983 to 1991. Here's 1983, 5037, and then 1991, 9977. So this would be your X1, Y1. X1, Y1. And this would be your X2, Y2. And so you'd use your midpoint formula, X1 plus X2 over 2, and Y1 plus Y2 over 2. So we already know that the midpoint for the year is 1987. Okay, they already gave that to us. So we don't have to do the X part. Okay, because we already know this is going to be 1987. So really all we're interested in is the Y's. So this would be 5037 plus 9977 divided by 2. Okay, so working that out, and we get 7507 is the cost for 1987. Okay, so at this point right here, that's an estimated cost based on this graph, which, all things being the same, that should be pretty close to the actual figure, whatever that is. All right, any questions with that? Okay. For the equation, x squared minus 4, create a table. Here they give you the x values. All you got to do is find the y values. All right, so how do we find that? Plug those values in, right. So this would be y equals to negative 2 parentheses squared, and then minus 4. So negative 2 squared, that'll be 4 minus 4, and we get 0. All right, so that's 0 there. And then we plug 0 in, minus 4, and we get negative 4 out. And then plug positive 2 in there, and we get 0 again. Okay, so we're going to have 0, negative 4, 0. So that's what we put in there. 0, negative 4, and 0. And, okay, from there, you're going to be asked to graph it. Okay, now you've got to click this little box down here below that in order to engage the graph. There it is. Okay, and so we're going to, what kind of a graph is this? Is it linear? Is it parabola? Is it cubic? Is it square root? Is it a circle? Anybody know with this x squared?
Parabola.
Parabola, good. So we've got to click the parabola, and then what we're going to do is we're going to do the vertex first, 0, -4. So here's -4, and then we click it. I must have clicked the linear equation instead of the parabola. I thought, oh, I know. So try it again. Parabola, and then 0, -4. All right, let's try. So this is at +2, 0. Let's see what happens there. Oh, I see. And then we go to -2. So you go ahead and plot your middle point first, your vertex, and then your two other points. And this is quite an unusual program because normally the parabola comes right from the beginning, but here you have to plot all 3 points. Okay. Now if you did the -2, 0 first, then 0, -4, you probably could still get it to come out right. Let's see if it does. All right, so we'll do the -2, 0 first, and then the 0, -4. There we go. Yeah, okay, that works too. All right? Okay. All right, questions with that? All right. Okay. Here you're going to choose the correct graph. Some of these you're going to have to graph using the palette. Now here, if it's inside, basically you have to remember what a square root looks like. Y equals to the square root of x. Starts off at the origin and goes up and to the right. But here, with x minus 5, this is going to make the graph move to the right 5 units. Okay? And so that means that since this is 10 right here, 2, 4, 6, 8, 10, okay, which graph? We would be looking at graph A, right? So none of these other graphs are even close. All right, questions with that? And now let's get back to this for a second. So looking at this, okay, this is at 5, right? Now it doesn't ask you this question, but there are questions that will ask you this. What is the domain? And give that in interval notation. Well, where does it start at? For the x values. 5, right? And that's a definitive point right there. So is that going to be open or closed? Yeah, that's right. It's a bracket. It's going to be closed. And this is going to go on to infinity, right? Now, is infinity open or closed? Infinity is always open. It has a parentheses, right? Good. Now, how about the range? Now, the range are for all the y values, right? But the range actually starts where? Here. It doesn't go on to, here's positive infinity, here's negative infinity, but it doesn't go to negative infinity. Where does it start at? Y is at 0, right. Y is at 0. Okay, that's a definitive point at 0. So this would be closed from 0. And now this keeps on going. It looks like it flattens out, but it does keep moving up. So that would be to infinity. Okay? All right. Questions with that? All right, the test won't ask you a domain and range on this particular question, but it'll ask you for domain and range on other questions that are similar to that. Okay? All right. Complete the following table. So this here, it'll ask you for -1, it'll probably ask you for 0 and positive 1 and 2 and so on, 3. So we had absolute values on the last, so this would be -1 minus 6. Okay, and what are we going to get out? Yeah, positive 7. That's right. And then we're going to put in 1, right, and 2 and 3 and 4 and so on. And then it's going to give you the values, and then you're going to have to graph it just like we did the last time. All right? Questions with that? But instead of, let's show the other palette. But in this case, you're going to have to use the absolute value button, okay, instead of the parabola or the linear equation, okay, to graph the absolute value. So you have to know, what the absolute value is going to look like, okay. All right, any questions with that? All right, so basically you just follow what the points are. Okay, and then for a cubic, same thing. Put -1 in here. You're going to get -3 out. And then 0, you're going to get -2. 1, you're going to get, or no, wait. Yeah, 1, you're going to get a -1. And then 2 cubed is 8. You're going to get 6 out. All right, and then you graph it. All right, so what are we going to click this time? Okay, one thing that you could do is it going to be linear? Is it going to be absolute value? Quadratic? Here it tells you cubic. Okay? And so we would put in here -1, -3. There's 1, 2, 3. 0, -2, and 1, -1. I would go to 2, 6. I would go up to 2, 6, and we're going to need one more. Looks like we need all 4 of them, and then we're going to. So and then you need the 1, -1. So you got to plot all the points in here. Here's 1, -1. So you need all 4. If they give you 4 points, you got to plot all 4 points in there. Okay? You can't take any shortcuts with this, because for this it won't work. You'll get the wrong graph. Because with 3 points, I got a parabola. All right? You got to use all 4. Okay, questions with that? Okay, find the center and radius of the equation of the circle described when you have center 0, 0, radius is 2. Okay, given our equation of a circle, okay, which one would it be? A, B, C, or D? Well, what is our equation of a circle? I'll give you a hint. X minus h. All right, then what? Squared. Parentheses squared. All right, then what? Plus y minus k. Parentheses squared equals to, good, r squared. So if this is x minus 0 squared plus y minus 0 squared equals to 2 squared, which equation are we looking at? Yeah. So we're talking about A, B, C, or D? Yeah, C. All right? Because this will be 4. Okay. Find the center and the radius of the equation of the circle described, and then graph it. Okay, again, you've got your x minus h parentheses squared plus y minus k parentheses squared equals to r squared. Center is not h, x, and y, it's h and k. Okay, so this would be x minus what? 0 parentheses squared plus y. Good, because that's minus a -1, right? So that's going to make it a plus 1. Parentheses squared equals to what? 36. Good, 36. And so we end up with, we can just drop the 0 and just make this x squared plus y plus 1 parentheses squared equals to 36. Okay, so they want the equation in standard form. Just type in equation, simplify your answer. So let's see which way they want it. So we're going to put in here x squared, move it right arrow, plus, and then parentheses, y plus 1, close it, and then exponent squared, right, equals 36. Let's see if it takes it that way. Okay, good. It takes it in. It'll take it in your standard form. Okay. And then we're going to use the circle. Start with, and we're going to use this equation here. Actually, you could use center 0, -1 also. That would probably be easier. Here's 0, -1. X is 0, y is -1. So that's actually down here. And you want to check your scale. Make sure, see, because here's 10. You know, because the scale can change on these. And then from here, just go across. 1, 2, 3, 4, 5, 6. And I went down 1 by mistake. Okay? All right. And there you go. All right, questions with that? Okay. Use the graph below to determine the equation of the circle, center, and radius. Okay, basically, the center. How do you find that? Okay, we want that point right there. Okay, how do we find that point? We use one of the formulas we learned in this unit. The midpoint formula, right. x1 plus x2 over 2, write it out. y1 plus y2 over 2. Okay, and you can use, and then you've got your 2, 2, right, and 8, 2 are your endpoints. Label it, x1, y1, x2, y2. And so this will be 2 plus 8 over 2. And the other one's going to be 2 plus 2 over 2. Well, this will be 10 over 2 is 5. And this will be 4 over 2 is 2. So our center is at 5, 2. Now, how about we want to find we need to find the radius next. Okay? We need to find the radius. Well, the radius is from the center out, right? So how are we going to find that? Well, if you draw a line all the way across there, right, what do we got? Okay, the diameter. And then what would be the radius in relation to the diameter? It's half, right? Radius is half. So if we can find the diameter, then we can find the radius from there. Well, how do we find the diameter? It's another formula we just learned. Sydney? I'll give you a hint. It's one that you learn right with the center of the midpoint formula, the distance formula. If you find the distance between these 2 points, you find the diameter, right? So distance, x2 minus x1, parentheses squared, plus y2 minus y1, parentheses squared. What else do we need? The square root. Don't forget that. Sometimes people do that. All right, and so this will be your 2 points we said were 8 minus 2, parentheses squared, plus 2 minus 2. Well, that kind of makes it easy because this turns out to be 0, right? So that would be 6 squared. It's 30 squared of 36. And so the diameter is 6. So therefore your radius would have to be what? 3, right? Okay, so in now they want it in general form. But what you have to do is you got to put it in standard form first and then put it in general form. Okay, so here's our center, 5, 2, and we have our radius is 3. Okay, so our equation is x minus h parentheses squared plus y minus k parentheses squared equals 2r squared. And center, what is that in relation to this formula? X, y, or r, h, k. H and K, good. H, K. X and Y is always going to be the points on the outer, where the curve is. Okay, this is X and Y. This is H and K as the center. Okay. So this would be X minus 5 parentheses squared plus, and then y minus 2 parentheses squared equals 2, 3 squared. And so now we have to square these, right? But what do we have to do here? This x minus 5. Is it just x squared minus 5 squared? Or do we got to do something else? Foil it, right. That's x minus 5 times x minus 5, right? And then y minus 2 times y minus 2 equals 2, 9. And so this would be x times x is x squared. This would be minus 5x, and minus 5x is a minus 10x. And then minus 5 times minus 5 is plus 25. Plus y times y, that's y squared. A minus 2y, and a minus 2y is a minus 4y. Negative 2 times negative 2 is plus 4, equal to 9. So now you put, what goes first?
X squared.
Yeah, the highest exponents. The x squares and then the y squares go first. And then minus 10x minus 4y go next. And then plus 25 and 4 is 29, but we have to move that 9 over. And so that'll be 20 plus just 20 equal to 0. And that's general form. Okay? All right. Questions with that? Okay. That's the same thing. Okay, distance formula. The midpoint formula and the center radius formula, equation of a circle are closely related. Okay, first thing, now they give you 31, 32, and 33. Now this one is 3 points. It's like they put 3 questions in one, but instead of making it A, B, and C, they made it 31, 32, 33. So I just made it 3 separate questions and made it 3 points. But it all builds from one to the next. Okay? So the distance formula, the midpoint formula, and the center radius formula of the equation of a circle are closely related. Circle has a diameter with endpoints -1, 2, and 5, -8. So you have these 2 endpoints. Find the center radius form of the equation of a circle. Okay, first find the center radius form of radius, and the coordinates of the center must be found. Find the coordinates of the center using the midpoint formula. They tell you which one to use. Okay, so first thing you're going to do is find HK, the center. Next thing they want you to do is find the radius using basically the distance formula and divide by 2. And then they want you to put it into the equation. So basically it took, one of these other ones, this one, and they broke it up. It's the same problem. Only this one they broke up into 3 parts. The other one you got to do it all in one. Okay? But it's the same thing. All right, same thing with that. Let's see. Decide whether the following relation defines a function. Okay, now basically I gave you a basic general definition for a function. Remember what that was? For each, right, for each x there's only one y. Okay, that's the simplest and the easiest way to remember that. The book gives you all kinds of technical definitions, but that breaks it down into its basic, easy to remember. Okay, so for each x, is there only one y here? You got 4, 5, 1, 5, and 5, 4. Okay, so can we say these x's all have their own y, one and only one y? Well, the 4, that has a 5. Are there any other 4s? X values as a 4, I mean? There isn't, right? What about the 1? That only has 5, right? 5, 4. So can we say this is a function? Harley? Yes, that's right, it is. Now, if we had something like this, 4, 5, 3, 2, 4, 7, 5, 9, is that a function? That's right, it's not, because the 4s have both a 5 and a 7 in it. Okay? So that's not a function because the 4s do not have only one y. All right, good. Okay, is this a function? Does each x have only one y? Yeah. The y's can have more than one x, but the x's can't have more than one y. All right? So that it would be a function. All right, decide whether the relation on the right defines a function in a given domain and range. Okay, we got 2, 8, negative 2, 8, negative 3, 12, negative 4, 16. Is that a function? Yes or no? Yes, it is. Okay, now we want to define the domain and the range. Okay, the domain is basically what? Good. All the x values. Negative 2, negative 3, negative 4. The range, those are all the y values. 8, 12, 16. Okay? Good. Okay. Now there was a way to tell by looking at a graph if it was a function or not a function. What is that method called? It's some kind of a test. Good, the vertical line test. So if we draw a vertical line anywhere, can we say that that vertical line crosses at one and only one point on the graph? Yeah. So can we say this is a function? Yes, we can. Good. Now we wanted to define the domain and the range. Well, this line, see this arrow here, is going to keep going and going and going and going and going forever. And going and going and going and going and forever the other way. So we can say that the domain is what? It's going to keep on going, never going to stop. So what is that? Good. Negative infinity to what? Right. Positive infinity. And those are always open, right? What about the range? Here's our range, right? What about that? Same thing. Good. Okay? So if you're not sure about the range, draw that range out in those arrows, and that might help you out. Okay, that tends, because the range can be a little bit, a little bit more trickier for some people, and so that helps them out. Okay, vertical line test. Is this a function? It's not a function, right? Because if we were to draw a line, it passes through more than one. Each x value has more than one y value in it. Okay? Now, the domain. Okay? It doesn't go on forever, right? It does for positive, but what about the negative? Yeah. And so, can we say that this is a definitive point here? Or is it, so in other words, is that open or closed right there? Closed, good, at -5, very good, to infinity. And how about the range? Does that go on forever, positive infinity to negative infinity? Does that go on? Yeah, it does. This keeps going, 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 higher and higher and higher, and it goes. So we can say that this is what? For the range. Travis? Right. Negative infinity to infinity. Good. All right, questions with that? All right. Decide whether the relation defines a function. Now basically, as long as you don't get a y squared, right? Because y squared is like a sideways parabola. Or if you get this, plus or minus the square root of x, it's the same thing. Okay? So as long as you don't have a y squared in it, for the problems that we're working with, then it's a function. So we can say that, yes, this is a function. Okay, basically, all we're doing here is what? Yeah, substituting in for x. All right. And use the graph to find the function of each. Now this curve, this line here, that's f. So if we're looking at f of -3, for example, we go here to -3, okay, and we find that where x is -3, y is what? Right there. 0, right. Now what about f of 4? Well, here's 4, right? Go up here. Okay. So that's basically 4 what? 2, right. 4, 2. Okay? So that's how that works. All right, use the graph to find your solution to the function. All right? Questions with that? Anybody need to see another one? All right. Okay. Graph the linear function, identify a constant function, give the domain and range. Okay, you can use any method you want. Probably the easiest one to use would be the slope-intercept method. So basically, what would be your slope and what would be your y-intercept? Well, slope-intercept method is y equals what? Good, mx plus b. Well, what's m? 1/4. What's the b? -2. All right, and where do you start on your graph? basically here. Negative 2. So basically this is like saying x is 0, y is negative 2. Okay, that's your y-intercept. Okay, you start at your what? Your y-intercept. Then what are you going to do? Go up 1 over 4, right. And then it'll draw your line for you. Okay? Good. Which one of these do you use? There's a line, there's a parabola, absolute value, y squared, circle. Which one? The line. Use the line. You got to choose the right curve. In this case, it's not really a curve; it's just a linear equation. But I think, all right, you got to choose the right graph for that. If you graph the line here again, you can use the slope-intercept method or the xy-intercept method. Either one. Okay. Anybody need to see how to do this one? All right. Graph the line. Question. Is this going to be a vertical line or a horizontal line? Good. It's going to go through the x. Because x is always going to be negative 1, so it has to go through x at negative 1. Okay? All right, good. Use the slope formula. Slope of the line. Okay. What is the slope of 2 points equation? M equals what? You can remove this, guys. Give you a hint. This is x1, y1, and this is x2, y2. And what's our equation going to be? Right. y2 minus y1 over x2 minus x1. All right, good. Label these points. X1, Y1, because you don't want to get it wrong because you put the wrong points in the wrong place. It can happen. All right? Okay. Questions with that? Anybody need to see what's up? You can remember this formula. Find the slope of a line. Okay, how do we find the slope?